Hello and welcome everybody to today's SimScale webinar. This is a product update and we'll be going over the latest product releases in the last sort of 3 months or so. I'm joined today by John Wild, who is VP of Product. So hi John, and thanks for joining me today.
Hey everyone.
Yeah, my name is Alex Graham and I'm a Product Marketing Manager here at SimScale. So let's get into it. Even though everybody here is probably familiar with SimScale, there may be 1 or 2 folks on the call who are not, and so we'll just take 30 seconds very quickly just to go over sort of the motivation behind all of the new features that we're showing you today. So SimScale is aiming to empower engineering teams everywhere to innovate faster by exploring thousands of engineering decisions in seconds. And just to unpack that statement a little bit, I mean, at the core of the idea there is equipping teams with the right environment, really. So one that combines accessibility with ease of use and cutting edge modeling capabilities, and all of that delivered in an accessible and cost-effective package. It can also scale very easily across organizations to truly empower innovation. And then the second part of the sentence is about how we want to sort of enable that innovation to happen at ever faster speeds. We want to collapse that whole process, the whole engineering decision-making process down to seconds. And we're doing that through the cutting-edge AI tooling that we're building into the platform at the moment.
Can I maybe share a point of view on it as well, Alex?
Yeah, absolutely.
So I think I look at it similar but a bit different. So for me, the empowering teams everywhere is because it's easy to use. Mm-hmm. We can see that most of our new users have like close to 100% success rate, even with their own models, which is amazing, right? So we can see that they're very successful from the beginning, and it's super accessible. So they can just not have to download or install anything. They can just get a login from their admin and they're off to the races immediately. And then the exploring thousands of designs in a second, I would say kind of similar to what you said, apart from the scalability part, right? So you could set up 1 or 100 simulations and run them all in parallel in the cloud, or you could leverage AI and run thousands if you wanted to.
Nice. Okay, so this is the outline of today's presentation. So we're going to get straight into the new features. I think first, John, you're going to talk a little bit about how the new features are actually released into the product, just to give people a bit of background to set the scene. Then we'll get into new capabilities. We've broken those out into sort of the domains. So we have physics AI followed by fluid dynamics or CFD and structural analysis or FEA, electromagnetics, and then we have some new features which kind of cover the whole spectrum there. So we've got some general platform updates and user experience improvements as well to talk about. So let's move on to the first slide here. And so yeah, maybe John, you could take us through this one and just describe the process and what we're looking at there on this screen.
Yes, I can do. Maybe it's worth also explaining, as I start sweating more during this meeting, it's because I'm in a new small box inside our office, which is meant to have air conditioning, but I've discovered in the last 10 minutes that air conditioning is not sufficient to offset the heat generated from the line. So the temperature is only going to increase as we get through this presentation.
So let's try and keep it brief.
Yes. So yeah, how we release new features, I think, is interesting, and it's different to how at least I've worked in the past with traditional tools. So maybe it's worth talking about how it used to work in a way. So with traditional tools, you might get an update every quarter, every 6 months, and then your company might update every year. Once all the validations have taken place and once everyone is ready to kind of migrate to the new version, and so you have to wait for new features. And SimScale works differently. I know that it's also a challenge working differently, but I think we've got it working in a really nice way. So as soon as features are ready, they're released to the platform immediately. That might be solver updates, that might be new features, or new solvers entirely. And we have it done in quite a controlled way. So every time we update something that could change results, we have to run thousands of automated tests to make sure that the variability is really small. And even with some customers who are running templated workflows, we even run their workflows for them to make sure that we're getting the same results, so that there's no kind of surprises and we always meet expectations. But the really cool thing for me is that as soon as something is ready, we can just release it to customers. And so as soon as you log into SimScale or refresh your browser the next time, you'll have that feature, could be super powerful, just sitting there waiting for you to use. And in the bottom left, there's a link to our website where you can see the roadmap. That gives you a few different things. So on the left, you'll see things that are still under consideration that we might move into development. You can vote on these or add more if you want to. Then we have everything that's in development. And then on the right, everything that's recently released. So you can look back over the last years, I think, and see what we've released and why we've released it as well.
And so users can go and actually add comments as well to those ideas that are under consideration and sort of weigh in with their views on on how those will affect them. Yeah,
exactly. And it does make a difference. Yeah, I've had plenty of discussions with users who, even students, I think, who didn't expect a response from me, and who've just put comments here, and I think I've responded to everybody that's ever shared anything here. So yeah, for sure.
Very nice. All right, so yes, with that in mind, let's get into the new features. So the first ones we're going to talk about here are AI. And so there's been a lot going on in this area, isn't there? So we can see there on the screen some of the new agentic AI capabilities which are coming soon. So you may well have seen us talking about those already. Those are something we're really excited about. Today, we're going to bring some updates about physics AI. So this is all about being able to accelerate predictions into a matter of seconds. So taking simulation results from hours down to seconds using surrogate modeling, essentially, so that you can train a physics AI model from your simulation data. So what is this this update here talking about, John?
So, I mean, you summarized it honestly quite well. So this is essentially creating a surrogate model or an AI predictive model of something that you already have running in simulation. You tend to need something like 20, 30 different simulations. Obviously, the more you give it as a kind of training data set, the more accurate it will be. And you'll see on the right there, it will give you an idea of how accurate the prediction that it can provide already is. And you can see as well that you can change boundary conditions, change settings, change models, and get an instant prediction into what those results are going to be. I think the most important thing for me is, well, two things actually. One is easy to train models. So if you've got some simulations already inside SimScale, you can say, okay, give me all those, put them into a model and train a model. And then you can immediately use it, publish it, and share it within your company if you want to. But the other really important thing, I think, is that we all know AI isn't 100% accurate. You might get 80, 90%, but it almost doesn't matter, because if you can get something like, I don't know, a 10, 20% improvement in your design, even if it doesn't work 100% of the time, it doesn't matter, because you might get a prediction that's really interesting. And because we have our AI sitting next to the traditional solvers, you can immediately run that new suggestion that AI has and validate it against a traditional solver and make sure that this potential improvement is really what you're going to see in the real world. So I think so the two things are easy to train, and the AI sits next to the traditional methods. So the setup and everything is the same, and you can choose the route that you take, AI or tradition.
And so this has been available in the product for, like, is it a couple of years now? But I think what's new here is that it can now be used with the multipurpose solver, as well as some of the others which were available before. And so this was released back in, I think, around February. And if you're interested to learn more about it, you can find, there's a link to a webinar here, which is, I think, with you, John, and a customer, and you go into, I think it's a live demo, and you can talk about it in a lot more detail.
Yeah, I think you're right. The main kind of new things are that we are partnered with NVIDIA. So NVIDIA Physics Nemo is now on the platform, which gives us a bit of additional capabilities, because we can now extrapolate essentially, instead of only kind of work in a smaller design space. And like you said, it's now compatible with the multipurpose solver. And now everything we release will be AI ready.
Very nice. And so, yeah, as we were talking about the last slide there, you mentioned data sets of like 20 to 30 runs, which I think is nicely brings us onto this topic about foundation models. So this is about sort of trying to help customers to get over that initial barrier, isn't it? So where in order to sort of get that value from using physics AI, you need to invest a certain amount of effort into either generating synthetic training data or using existing simulation data that you have from previous runs in order to build that model. And then then you obviously need to kind of validate the model and get it ready for use. And so the foundation model is quite an interesting new idea. So it's helping people just kind of start that ascent from base camp, so to speak.
Beautiful analogy.
So what are we doing? What are we doing here with foundation models?
Yeah, I think the big difference is that you don't have to pre-train. So normally with an AI model, like you said, you need to do some kind of training. With a foundation model, we or someone else has done all of that training for you. So the example we have, or that we've been using recently, is a pump. And there, I mean, we did quite a lot of broad training on about 50 different models with lots of different simulation setups. But now we can give it a pump that the AI has never seen before and get still a pretty accurate prediction. So it's different, and it moves away from needing to pre-train. That's the main kind of key element, I guess.
So it's like giving customers a kind of pretty solid starting point,
Mm-hmm.
which should already give decent results, and then they can fine tune it with their own data to create something kind of proprietary as well.
Exactly. So like you said, you're already starting at base camp, but you just need to do the last bit. I guess it makes sense now. Nice.
And so, yeah, there's another link on this slide to another webinar, which is all about this particular topic. All right, so now on to CFD. And I think this is both of our favorite topics. Is that fair to say, John?
Yeah, I shouldn't say I have a favorite, because I think I'm meant to be pretty,
you should
what's
be
the
neutral.
word? Impartial.
Yeah.
Yep, exactly. But yeah, CFD is what I've done for 20, 25 years. So I think it's my favorite because it's where I'm most comfortable, I guess. It also produces the coolest looking pictures, I think.
So yeah, we've got a few features to talk about in CFD, and we're going to start here with a pretty meaty one. And this is something I feel like I've learned a lot actually about heat exchangers by doing some work on the launch of this new feature. So this is all about high performance heat exchangers and the workflow needed to model them in CFD. So this is essentially a way of using novel CAD techniques called implicit modeling. So if you haven't heard about implicit modeling, absolutely recommend you check it out. It's absolutely fascinating.
I think the main important thing for me here is that, like you said, really, it's a new way of modeling CAD. So you can't create CAD models of this complexity and with this kind of organic structure with traditional tools. You need to use implicit modeling. And although we could already simulate heat exchangers pretty easily, it was hard to take that geometry or this type of geometry and mesh it in the traditional way. We always had to import it, convert it back to like the standard type of CAD format. And that's problematic. That often introduces errors, and it takes a long time to run. But we don't need to do that anymore because we can import the native nTop geometry, and then we can simulate this really complicated structure and get nice results inside SimScale. So I think the real benefit now is that we don't have to go through the translation, so we don't lose any granularity in the geometric model, and because we use our immersed boundary method, so we don't have to mesh it to crazy kind of detail levels, but we can still capture the detail. It doesn't take long to mesh, and it doesn't take long to simulate either.
So there's another link here to a webinar we recently ran with nTop, where we demonstrate this process and go into it in quite some detail. And we're going to play a short clip from that webinar now, just to give you a bit more background into this.
I want to quickly show you a summary. So what we did is we used nTop Core, so nTop Core library from nTop, to put it essentially into our workflows on SimScale. So that was great, running this partnership with nTop, getting the support to pull this in. That allows us now to directly import implicit models from nTop into SimScale. Currently, we then run CFD and thermal simulations on those. As I mentioned, we could also in the future run structural or other types of simulations on these geometries. There's still the traditional way of using faceted, but the real reason to do this integration was getting rid of this workflow. So here in the context, you can see this workflow really avoids a surface mesh or tessellation or facetation, whatever you want to call it, though that tedious workflow step where you need to decide how fine you want to resolve the geometry to bring it into a simulation tool, so that you have this trade-off of time that you need to create the tessellation, import the model, file sizes that you need to store. And on the other hand, you don't want to have already the geometry resolution affecting the accuracy of your simulation results. That's pretty bad. So that's why we want to avoid that trade-off, bringing in directly the implicit models and then only doing an approximation in the numerical method of meshing and simulating those models.
Right, so now we're on to our next new feature in CFD. So I guess maybe compared with the one we were just talking about, this is relatively simple in that we have introduced a new turbulence modeling option for conjugate heat transfer.
The main thing here is that we're giving users a bit of choice, so they can choose the right turbulence model for the right scenario.
Yeah, makes sense. All right, and then the next one here is about surface refinement options for the multipurpose, or rather the mesher in multipurpose analysis type. So yeah, the challenge here was I think that previously it's not been so easy to sort of have detail control over the mesh refinement on particular surfaces. So if you have like a leading or a trailing edge of a wing or a blade, or like as in the picture here, this is that's like an internal interface between a moving part and a stationary part, I think. So somewhere where you might want to refine the mesh. So yeah, what's changed here then?
I think maybe thinking about how the other analysis types or solvers work inside SimScale is a nice kind of analogy. So we add lots of different solvers to SimScale, and this is a commercial solver. And sometimes it takes a while to kind of bring them up to the same level as how everything else works. So generally, with meshing, what we try to give our users is total autonomy. So you should really just be able to press go. And SimScale will look at the physics and define the mesh accordingly. So it will know where there's going to be high speed and refine the mesh there. It should know, like this example in the bottom right, where there is slightly more complex or curved geometry, and then it should refine the mesh for you there. Until now, in multipurpose, this wasn't applied. So it was using pretty standard meshing, but now it takes all of that into account. So it's a little bit more physics-based, and it will understand if there's kind of surface refinement requirements, and it will refine it for you. So the top left is how the mesh would have worked before. Results would have been fine, but on the bottom right now, the results will just be a bit better. Really, that's kind of what we're trying to do. So our users, again, shouldn't have to think about meshing. They can just press simulate and go.
Very nice. Okay, so I think now we're on to, this is our next meaty new feature. So yeah, it's almost not so much a new feature, but it's a whole new solver that we're now introducing into the platform. So you probably will have heard previous announcements about this. I think it was announced back in November of last year that we were starting this partnership with Hexagon, which was all about introducing the Marc nonlinear solver into SimScale. And so this is very helpful if you are doing very complicated, very highly non-linear structural simulations with kind of all sorts of difficult things happening, like sort of self-contact or arbitrary contact, where you don't know which surfaces are going to come into contact with each other. And so, yeah, what we're doing here is giving users a whole new solver that can be brought to bear on these kinds of problems.
Do you want to try introducing the image on the right-hand side by saying the title out loud without swearing?
So this is it's a 3D printed elastomer. I've seen it previously called a lattice puck, but now you're calling it an octet puck. But it's not something I had heard of before. But is it part of like a shoe? Am I on the right lines there?
It can be. Yeah, it can be. I mean, I think you would recognize this type of structure from within shoes, but it doesn't have to be that way. But yeah, it really can be. I mean, the main reason we use something like this is because it's very challenging. It's challenging because it's super non-linear, which is difficult to simulate anyway, and then has many contacts, which can be also difficult to simulate, and it's self-contacting. I mean, at the end, it's just one part really, and there's loads of different self-contacts, so it's normally very difficult to do. I think the good thing here is that even me as a CFD guy can set something like this up now with Hexagon Marc. The contacts work on a volume-based way instead of surfaces, but it's super easy to use. It's really cool.
Yeah, that does look like an insanely difficult simulation. I would have imagined. Yeah, so that's pretty impressive if that's an easy one to set up.
Even more that I can do it.
So yes, there's another link here to a webinar. This is an upcoming webinar actually at the end of July. Where we will be presenting this with Hexagon. So yeah, please do register for that if you'd like to learn more about it. And I think actually, John, you've got a few more slides with some more nice animations. So I could go on looking at these all day, really, because they're just quite fascinating.
I know, it's super cool. I think I would also add that this is available already for the community. So anyone who joins SimScale via the community, obviously you get 10 free simulations with results to test, and you'll be able to access Hexagon's Marc immediately too. If you want to give it a go, even with your own CAD models, please do so. And I think why it's interesting, it's really why it's interesting because of what I just described. So it's easy to use. That's for me like the most important thing. And it brings new different types of physics that we can use without necessarily having to be a simulation or structural simulation expert. Because I can set up these kind of models, even with the different load cases that work. It's easy to do and really robust. It's really fast as well. I'll give you a quick example. So our current solver, which is tried and tested, it's been around for decades. It works super well, but it takes something like 2 hours to simulate this ceiling fitting process and costs about 30 core hours. With Marc, it takes 25 minutes and 7 core hours. So it's faster and cheaper. And yeah, in the end, also more robust. So the one on the left, if I was setting this up, I would imagine it wouldn't work first time because there's lots of different contacts to think about, things that aren't in contact to start with that are in contact later. With Marc, you just pick the 2 different pairs of volumes that could or will be in contact, and everything else is taken care of for you. But it's so much easier to do and should almost certainly work first time. And it's very stable. So like I said, I'm a CFD guy. I think I can set up most CFD simulations without having to put in too much thought. Structural doesn't come to me as second nature, but with Marc, it seems to be very easy to use. And I thought I'd share some examples, just of things that look kind of cool and that are pushing the envelope a bit. So for us, at least, a lot of these different features are so non-linear with like buckling and compression and crushing. We couldn't have done anything like this before, but now we can. And it's also, like I said, pretty simple to do. So you can see there's a bottle collapsing, a basket being crushed and impacting and flexing and bending, permanently deforming. On the bottom left, this is interesting because it's an assembly. and it works in the same way as anything else. It's still easy to do, but here we've got something crushing the assembly. All the parts will move and contact and get deformed inside.
Okay, so let's move on to electromagnetics. So I think we just have one one update here to talk about. Yeah, so this is about, I guess, it's a relatively simple sort of idea that it's about being able to probe anywhere in the domain of an electromagnetic simulation, and then being able to plot the results from that to get localized insights as well as global results. How would you describe it, John?
It's exactly that. So, I mean, in CFD and FEA, probe points are already implemented and working. So like you said, you pick a point or multiple points before you run a simulation, and then you can track those results throughout the steady state or transient simulation. But like I said before, this is also a commercial solver that has now been added to SimScale. And sometimes it takes a while for us to add all of the different features. So everything else already have probe points, and now electromagnetics does as well.
Yeah, so I see a pattern emerging here, like with the some of the other features we talked about there before, like the meshing one and the turbulence modeling one, are all about kind of creating that same user experience and set of options across the platform in the different solvers.
Yeah. Sometimes that's easy to do. If the solver already has those capabilities, it's easier to expose them and have them connected to SimScale. Sometimes they don't exist already, so we have to build something in SimScale that works the solver in a different way to give our users that level of ease of use as we expect from SimScale. Sometimes it's a bit more challenging for us, but not for our users.
Yeah, and let's get on to pre and post. So yeah, again, I think there's some nice ones in here. So yeah, this is all about being able to extract series, well, sort of, I guess it's like multiple point probes that you can then plot into a line, so you can see the progression of a variable over a path.
Yeah, exactly. I mean, honestly, this is a feature that we've missed for a long time. Our users have asked for a long time. It's one of the top rated or top requested features, along with a couple of others which are also in development. But I think the thing here for me is the way we've implemented it in an easy to use way, I would say. So you first pick the points through the model. So you tell SimScale what you want to see and why. You can do this across multiple different cut planes, so it doesn't have to be on one. You can even pick on surfaces or so through a solid as well if you want to. And then you'll get a plot like you can see at the bottom. You can change the variables, so you could be plotting through a valve looking at temperature, then you can switch to pressure, whatever you want. And you can change the granularity here too, so you can do all of this after you've created the plot. I think it's super easy to use and get results really quickly and easily. And obviously, if you've done this, you can save the view like at the top, and then you could import that plot overline into another different model to use it as a template if you wanted to. So you could always have everything easy to compare.
Very nice. Yeah, I also had a quick play with this one. It did seem to be really, really simple. So yeah, very nicely done. So yeah, the next one, yeah, I really like this one. It's one of those. This is one of those things which is just very nice and reassuring to see. I think when you're, when you're trying to set up define something like, I mean, I think a good example is like if you're doing a simulation of a car and you need to define the wheel rotation, you obviously need to put in a center of rotation and a direction. It's very easy to get that information wrong when you're entering the data, and you won't realize that your wheel is rotating around a completely different point in space than it should be until maybe you run the simulation and you're sort of wondering what's going on with these slightly strange velocities on the surfaces. So yeah, it's really nice when you type in the number to be able to immediately see whether you've got it right or not. So yeah, like how do you see this one developing? I think you suggested there that you've got more plans as well beyond just showing you the arrow in the UI.
Yeah, I think so. I think what this shows as well is that we're a mature company and we have time to do this stuff that it's a bit nice to have, right? It's not super essential, but I think it is important, and it really helps to very quickly look at the model and see if everything is set up in the way that you would expect it to be. So as the air here, for an example, the air going in where it should be and coming out where it should be, so you can very quickly kind of see what's happening. And then as far as next steps, yeah, we'll continue to build on this. So like here, you still have to define the angle actually using vectors that the air could enter or will enter your simulation. But in the end, we'll be able to drag the arrow around, and it will be easier and easier to use. So we'll continue working on this, yes.
All right. Shall we move on?
Yeah.
Cool. So, this is like a pre-processing feature. So I think this is all about preparing your geometry, maybe defeaturing it. So if you want to remove things like screw holes, or another example it gives there is nameplates. Like if you've got like a name of a company or something machined into a part, and you want to select all of those like slightly internal faces, and just to get a smooth surface to take those out. Then this is a nice little tool, I think, isn't it, to help you select all of those in one go?
Yeah, it's exactly that. I mean, the pre-processing or the CAD tools inside SimScale are really to help you get from a probably more complicated or complex ready for production CAD model and get it more ready for simulation. So removing anything like these small holes that make no difference to the simulation should be easy to do. So this is what this is for, just to speed up that process of getting your model ready for simulation.
Very nice. Looks useful. And then I think, yeah, on almost like a related note, in my mind at least, the ability to pick similar volumes as well. So not just like related surfaces, but related volumes. And maybe nuts and bolts, is that a good example when you want?
Yeah, exactly. Yeah, nuts and bolts, heat sources. Yeah, exactly. Anything like this within your CAD model. So I'd think about it like it's useful like surfaces. If you've got lots of hundreds maybe of surfaces for inlets, you can pick one and then get SimScale to pick them all. This is the same kind of thing, but for volumes. Yeah, exactly. So it normally isn't so useful for cleaning up, but more at the part of setting up a simulation. So you might assign rotating regions, or you might assign heat sources. But like you said as well, you might have 1,000 bolts, and you could very quickly then just remove them from the simulation if you didn't want to simulate them.
Nice. Yep. So reducing mouse clicks. That's always welcome.
Yes.
And then, yeah, to round this off, we've got a few updates that kind of touch all of these different analysis types and are more about the actual platform itself. So, yeah, so the first one, super simple, but also super useful, I think. I certainly find myself using this feature a lot in like Google Suite or Office, or all sorts of other kind of applications that have this ability. Like rather than trying to dig out the file that you were working on and sort of make sure that it was the right one, checking when you last edited it and that kind of thing, you could go straight to just pick the most recent file that you worked on yesterday. It's going to be right there at the top of the list. So that's a really nice thing to see in SimScale as well. And I think is that pretty much how it works? So you just click on the recent projects on your dashboard, and there they are.
Yep, that's it. Exactly that. I think again, it's a nice to have, but for me, it's almost moving towards important. Not just nice, because it's such a time saver. It's so easy now just to find what you're working on before. So yes, it saves time. And
I guess it also reduces kind of scope for error as well, that you might actually open the wrong thing and start working in an old version of something. Very nice. And then we have another dashboard on the dashboard topic, and a new dashboard in the dashboard. Am I just confusing myself?
That was beautiful. That was beautiful.
But this is a new capability to help people essentially understand how they're using SimScale.
Yeah, I mean, for me, this is important. I mean, I like to be a transparent and honest person, right, in life. And I would like to lead SimScale in the same direction. And that's why we have this to some big part, you know. But our customers have asked a lot for data, and now we have it. And we've tried to do it in a very, very transparent way, which I think is right. So now all of our users can see how many licenses they have and how they're using them. Do they not have enough, or do they have too many? Their users can now decide, right? And you can kind of go into more granular levels too to see like how are my users in my organization doing. So I've got 100 different users potentially or more. Who's successful with their simulations, and could they train other people? Or who isn't successful and is not being very efficient? Are they in need of training, or are they using too many core hours with no kind of output? You can see all of that here, and then help those people, right? And help them be better and be more efficient overall as a business. So we're just trying to give as much information as we can so our users can make informed decisions.
That sounds very nice, actually. So that's giving you like a really deep level of understanding of the usage. It's a bit more than just like core hours and kind of license occupation. It's actually about how well it's working or how successful simulations are. I guess it's the kind of insight that you could only really get from a cloud native platform, actually, to be able to. Otherwise, it'd be very hard to put all that information together, wouldn't it?
I assume so, and I think so. Yeah, I mean, one of the reasons to do it in this way is because I then think it is pretty differentiated. So yeah, the license utilization part is quite easy, but the kind of deeper insights is definitely less easy. And soon we'll also have a split on the analytics to show you the difference between CFD and FEA, so you can start filtering your teams even to a more granular level as well. And maybe you should point out as well, this is so far only available for some of our larger customers. We're gradually going to roll it out to more and more over the next months, probably, maybe quarters. But if you'd like it now, just let us know and we can add it to your organization immediately. Like we said before, we can turn on new features instantly, and we can do that as well here.
Very nice. Yeah. So people can really optimize their use of SimScale.
I hope so. Yeah.
Yeah.
That's what it's there for.
Cool. All right. And that brings us to the end of our whistle-stop tour of new features. So yeah, thanks very much for joining me for this, John. I think that was really, really interesting and helpful. I hope everybody found it valuable. So please do put your questions into the Q&A panel. Unfortunately, we won't have a live Q&A today, but we will be able to get back to you very, very soon by email. And hopefully next time we will be able to do a live Q&A if we don't have any scheduling challenges next time round. So yeah, I hope my internet connection held out as much as possible for this. Yeah, thanks for joining, everybody. See you next time.
Thank you, everybody. See you next time. Bye.
Cheers. Bye.